Hello, my dear students. Welcome to my YouTube channel, that's Concepts of Chemistry. Before starting today's lecture, please do subscribe my channel. My dear students, today's topic for the lecture is second case of Vsepr theory, that's valence shell electron pair repulsion theory. And the second case deals with the order of bond angles in a same type of compounds with respect to the decreasing electronegativities of their central elements which belongs to the same group of the periodic table. And for this case, I am taking the example of hydrides of group number 15. Hydrides of group number 15. The hydrides of group number 15 signifies that I am talking about same type of compounds. Now, the hydrides of group number 15 will have the general molecular formula of EH3, where E is element of group number 15. So now, let's mark the members of the group number 15 over here. Group number 15, and they are nitrogen, phosphorus, arsenic, antimony, and the bismuth. So the molecular formulas of the hydrides will be NH3, PH3, ASH3, SBH3, and the BiH3. Now, all these are the hydrides of same group, that is group number 15. So, all will be sp3 hybridized with one lone pair of electrons and 3 bond pair of electrons, and the geometry will be called as pyramidal. So now, let's talk about the trend of the bond angle. As we move down in a group, what's gonna happen? The electronegativities, the electronegativity of the elements will decrease down the group due to which what will happen? Due to which bond angle of the compounds of the hydrides, moreover of the hydrides, will also decrease down the group. Now let's talk about the reason. Why so? Why bond angle is decreasing down the group with the decreasing electronegativity of the central element of the compounds down the group? Now let's discuss about it. For this, let's take two examples, NH3 and the PH3 with a detailed structure. I am taking my nitrogen to be over here. Its pyramidal structure. So we got the first lone pair of electron, that's the bond with hydrogen, so that's the bond pair. That's the second bond pair, and that's the third bond pair. Now, nitrogen has more electronegativity than hydrogen. Then what's going to happen? Nitrogen will attract these shared pair of electrons towards itself, due to which nitrogen will acquire a delta negative charge and hydrogen will acquire a delta positive charge. Same goes to the another bond pairs also. Nitrogen will be going to attract the shared pair of electron towards itself, acquiring the delta negative charge, and the hydrogen will acquire a delta positive charge, and the same goes to the third bond pair. Nitrogen is having more electronegativity than hydrogen, is going to attract the shared pair of electron towards itself, acquiring a delta negative charge, and hydrogen will acquire a delta positive charge. Now, what next going to happen? Here, nitrogen is having a lone pair of electron. Nitrogen is having a lone pair of electron which is a sort of negative charge, due to which this negative charge will try to pull this hydrogen with a delta positive charge towards itself. So that's the attractive forces. So I'm marking that's the attractive forces. So this lone pair will also try to attract this hydrogen with delta positive charge towards itself. Again attractive forces. And this lone pair will again try to attract this hydrogen with delta positive charge towards itself. Again attractive forces, which will cause in the expansion of the bond angle. So these attractive forces will cause in the expansion of the bond angle like this. But these attractive forces, the magnitude of these attractive forces is less than the repulsive forces between the bond pairs and the bond pairs of the CH4 molecule, due to which the bond angle will expand but will remain less than the standard tetrahedral angle of 109 degrees and 28 minutes. So the bond angle over here will remain less than the standard tetrahedral angle of 109 degrees and 28 minutes, because these attractive forces are less than the repulsive forces between the bond pairs and the bond pairs of the CH4 molecule, the standard tetrahedral geometry. So here we got the bond angle to be 107 degrees, and the lone pair on nitrogen atom will try to expand the bond angle. Now let's talk about the pH3. Now I'm talking about the pH3 molecule. So that's the phosphorus. Again it will have the lone pair of electron and a 3 bond pair of electron. Now phosphorus is more electronegative than hydrogen, so phosphorus will also again will attract the shared pair of electron towards itself, acquiring a delta negative charge, but I am marking delta dash negative, and here we will get delta dash positive. Now the second hydrogen will also acquire a delta dash positive charge, and the third hydrogen will also acquire a delta dash positive charge. Now here again what's gonna happen? The lone pair lone pair of electrons is a sort of negative charge, and this negative charge will again try to pull these hydrogen with a delta positive charge towards itself. But in this case, what's gonna happen? The electronegativity of, I'm writing, the electronegativity of phosphorus is less than nitrogen, due to which what's going to happen? The magnitude of delta dash positive charge which is present on the hydrogen of pH3 is less than the delta positive charge which is present on the hydrogen of NH3, due to which what's going to happen? The magnitude of their attractive forces, the magnitude of attractive forces the magnitude of attractive forces between lone pair and hydrogen will be less due to less delta dash positive charge on hydrogen. So here in this case, the expansion of bond will be less, or we can say the expansion of bond angle will be less comparatively NH3. So in this case, the bond angle will be 93.5 degrees. So I'm mentioning over here, due to this, what's gonna happen? The expansion of bond angle will be less comparatively NH3. So as the electronegativity of the element decrease, the extent of polarity or the charge separation decrease. So the attractive force between the lone pair of the phosphorus and the delta dash positive of hydrogen will be less. So the expansion of bond angle will also be less, and the bond angle will be 93.5 degrees, and in that in that of NH3 the bond angle will be 107 degrees. So this is the thing that I have proved. As the electronegativity of the central element decrease, the charge separation decrease, so the attractive force between the lone pairs and the delta dash positive of hydrogen will also decrease, so the expansion of bond angle will also decrease, thereby decreasing the bond angle. So I hope you got this thing. Let me mark the bond angles of the members of group number 15. In case of NH3, we are having the bond angle of 107 degrees. And in case of pH3, we are having the bond angle of 93.5 degrees. In case of ASH3, we are having the bond angle of 91.5 degrees. In case of SBH3, we are having the bond angle of 91.3 degrees. And in case of BiH3, we are having the bond angle of 90 degrees. Because the strength, the order of electronegativity, because the order of electronegativity decrease down the group. We can say that nitrogen is the most electronegative element in case of group number 15. Then phosphorus. After that, ASH, arsenic will have the less electronegativity. Then further antimony will also have more less electronegativity, and the least electronegativity will be of bismuth. So in this case, nitrogen is the most electronegative element. Then the second come out to be the phosphorus, third come out to be the arsenic, fourth come out to be antimony, and at last bismuth, the least electronegative element. As the electronegativity of the elements decrease, the bond angles also decrease. So that's all for today. I hope you got the second case of Vsepr theory. If any student wants to book a paid one-to-one online class to clear their doubts, then she can contact me. My phone number is mentioned on the thumbnail of this lecture. Please do like, subscribe and share this channel to maximum number of students. Don't forget to press the subscribe button. Stay blessed.